so people like, I think you're seeing the invisible. So that's, you know, what I think is a good example of that. You guys, let's take just a little couple-minute break, just a little stretch break. I know this is riveting. You're glued to your seats.
So the hypothesis for this reflection of light on the ocean to refraction through the
Yeah. All that.
Is that the actual reason?
Yeah, it has to do with the nature of the planet. It also has to do with how light passes through the atmosphere and what light is reflected and what light is absorbed and what light bounces back off of the Earth as well.
So the closer you are to the ocean, the bluer, whereas the more inland
More like the further up you go, the less blue it gets.
the further north you get.
No, the further away from the center of the Earth, so you start going up, and eventually blue turns into black. Have you ever taken a jet up, been on a flight where you're up to 35,000 feet? It's not quite black yet, but it's getting really dark blue. That's because those wavelengths are bouncing away. You're not seeing those colors. Yeah, that's cool. Although you know that Malaysian, it's really, I flew back from Europe this summer. You know, you're sitting in the seat and thinking, gosh, that would be a horrible way to go. I think of it just
So Malaysia.
it's terrible.
Not only is it's not just the impact, it's
What happens?
the vacuum.
Or just there's not a vacuum up there, but just before you die, falling free.
Well, I mean the vacuum out of the plane.
Oh, out of the plane, yeah.
You get sucked straight out, and that is the fall.
Right.
And you're alive for all that.
Sorry.
You okay? Did you fall asleep and wake up?
Like she got away, but she gonna hit. Do you want to see?
Yeah.
I'm sorry. I know it's bad to like laugh at this, but it's funny.
I have that sense of humor. Oh, this is the bucket challenge.
Why is she floating?
I don't know.
Oh!
Like she's
Oh,
always
my
going.
God.
I know. Like she's gonna drown.
Oh gosh, stop like that. It's very good. She was getting away somewhere, but that
You ever
looked like
watch,
cold.
what are those shows that come on TV with,
Yeah.
they're like obstacle courses that people have to run
Yeah.
across.
Oh, yeah,
They're
yeah,
sliding
yeah.
off.
Oh,
It's just like,
That is so funny.
Yeah.
That little rotating thing when they get on there, they stand up and have to like, yeah.
I love watching the ice cream.
is everybody back? All right. Just gotta get the blood flowing there.
They're still missing one.
Some outside. Oh, yeah.
That's it.
Justin, right?
Just,
All right, we'll get started again. All right, any questions so far? Nobody's falling asleep yet. That's good. That's nice. You guys are probably getting hungry. Ready for lunch. Okay, so, and then at that point, you know, you've made your observations. I like the bird thing. I just think, Matt, right?
Yes.
Matt did such a great job with that. I want to keep that front and center. So you have these observations. Birds use certain docks. They don't use other docks. Why? You know, what is the underlying mechanism behind that? The hypothesis is that there are fish under some docks and not fish under other docks. And we confirm that to be a hypothesis because it meets all the characteristics over here. At that point, you now start thinking about what would you do to test that. Okay, and this is a fairly simple case, so so that's good. And here's the test or the experiment. And you state your Where did that come from? You want to state your predictions with a certain study or experiment in mind, okay? And it's good to have it all laid out and all spelled out about what could happen when you do it. So we decided that what our test is going to be is we're going to, how are we going to count these fish?
We're gonna scuba dive.
We're going to scuba dive. We could do an observational thing. Or why don't we electroshock them?
Okay, I like that.
We'll do that. We've got one here on campus, a backpack electroshocker. It doesn't kill the fish. You put your electrodes in the water, you hit the button, it stuns them. They've got swim bladders, so they float up to the top, and you scoop them. So you can very systematically, that by the way is how the state of North Carolina assesses how many fish they have in one place. You can carry a backpack and walk through a stream. You wear lineman's gloves, it's really cool. You look like you're from Ghostbusters. Or you can use a boat that's specially outfitted for electroshocking. So if you want to catch, big bass in lakes and see what's there, you've got a boat that does that. So of course you have to be very systematic about it. You got to zap the same amount of times around both docks. If you zap more than around one dock than the other dock, you could be getting more fish because you're zapping more in one area than the other. So you have to be very systematic about how you do the study. So predictions have generally this format. If I do this experiment, I use an electroshocker and shock equal amounts around the two docks, and it's true that there are more fish next to one dock than another. That's the hypothesis. E stands for experiment, H stands for hypothesis. If that's correct, then F. I will get another set of facts. I'll have, I'm either going to get, let's just call them docks A and B. I'm either going to get the same amount of fish at A and B, or I'm going to get more fish at dock A than dock B, or I'm going to get more fish at dock B than dock A. There's no other, I can't think of anything else that I could get. I mean, I could get no fish anywhere, but then A is equal to B. So I've defined the universe of outcomes I could possibly get. And then I kind of decide if my, let's call this the bird dock. That's my bird dock. So which of these would support the idea that the place the bird's going is because of the fish?
The second one.
Second one, okay? Because in that particular case, the bird dock has more fish than that one. Both of these would falsify the hypothesis, and this would fail to falsify the hypothesis. So I have it all thought out ahead of time. The last thing you want to do is go in there and just start doing stuff without going through the mental process of understanding what my possible outcomes are. And then comes the fun part. You put on your electroshocker, you put your electrodes in the water, and you start scooping fish. And you start counting. And would you be interested in just counting the number of fish?
Types.
You want to maybe, look at the types. Maybe they don't
The
like
size
to eat.
of fish?
Hmm?
The size of the
The
fish?
size of the fish. Yeah, maybe there's more fish over here, but they're little puny things. And over here I have fewer fish, but I get, big honking fish. And one big honking fish will feed me for a day. So, the size of the fish could be important too. Whenever you go out there, you don't want to just collect the data that you're interested in. If there's other data that comes along with it, pick it up. Write it down. You have access to that, and who knows? Something might come up that, and this happens probably anytime you do science. You're looking for one particular thing, but usually you see something else. Like suddenly you start noticing, gosh, these fish have lesions on them. So I wasn't interested in fish health, but suddenly, wow, the fish in Lake Hickory are pretty nasty, sick-looking fish. What's up with that? And then that raises a whole bunch of other questions that had nothing to do with what you were originally. I mean, you'll answer your question, but then you'll have all these other things like, wow, or Or you might find a species that people didn't know were in Lake Hickory. So all kinds of stuff, that's what makes it kind of a lot of fun, because you never know what you're going to get. So then you do it. In your textbook they call it a test. We can call it an experiment. We can call it a study. And they say results, but results are really nothing more than just more facts. Again, what's a fact? It has to be what? Measurable, observable directly or indirectly, and based in physical reality. Okay? So counting fish, that meets that criteria. So really, this is just up here again. Okay? But what we do with those results, one of two things. Either I'm supporting my hypothesis or I'm not supporting my hypothesis. Okay? The word you don't want to use is that word right there. Put a big X through that. Scientists don't prove anything. Now, you'll hear lots of scientists use that word, but technically it's not correct. All that we do is we either, you can use the terms support. I can support my hypothesis. I can, and what's even better is a fail to falsify. I can fail to falsify hypothesis, but I don't prove it. Proof means without a shadow of a doubt, that's the way the world is. And there's nothing that can happen beyond that that would make me think anything else. Okay? Can somebody tell me why we didn't prove anything?
Because some birds are different.
Some birds might be different. What if, yeah, you do get more fish at the bird dock than at the other dock. But what if there are more people at the non-bird dock? And they, light off fireworks over there so maybe, you don't know how many fish a bird needs. Maybe having fewer fish is enough for that bird. And it's really not going there for a different explanation that you haven't investigated. Okay? So that's why we haven't, there can always be another hypothesis. So I can support my hypothesis, but I could be wrong.
Might be a cat over there.
Huh?
Cat.
Maybe there's a cat over there that only comes out at night, but maybe all it takes is one time seeing the cat, and you don't know that, but somebody at the marina says, well, isn't that where old Pegleg used to live, that that old cat? Yeah, he's a real bird eater, that one. So we don't prove things in science. The best that we can do is continue whittling away at what we think is the truth, and after a while, now, this isn't how are we doing on time? That clock's slow, isn't it?
It's 11:57.
Yeah.
It's 11:57. Okay. Eventually what starts happening, so in this particular case, yeah, we could probably keep going with this, and we would have a larger investigation of what determines the distribution of birds. Why do we find birds in some places and not other places? And basically what we're investigating we could call the prey hypothesis, and that animals will be where they are depending upon how much food they can catch or how much food they can ingest. And that would be then one kind of large set of explanations that would explain the question of why are animals in certain places. It would sort of stay in the realm of hypotheses if we were just talking about this particular bird, but of course we'd have to look at many different birds of this species and look to see, are they also in places where there's a lot of food? And then if we want it to be a more general explanation about, remember, we're trying to explain physical truth. That's what science is all about. We would have to look at other species also. So we would have to do many, many experiments on different species, on this species, in different ways before this is a sort of a general body of knowledge. If doing those experiments over and over again, we keep getting the same results, and we keep seeing that animals are found in places where typically there is a lot of food, we start calling that a theory. Now, mind you, a theory is nothing more than it's still a hypothesis. It still has all the characteristics of a hypothesis. Which means it still has characteristic number 4, which is it still has to be, well, it still has to have the ability to be falsified. Okay? This is something people forget about in science, is that they think that scientists prove things and that we establish facts. Scientists don't establish facts. Anyone can observe a fact. Okay? You don't need a scientist to do that. Okay? So it still has to have the ability to be falsified. What's different about it is that particular hypothesis has been tested many different ways in many different experiments, and the preponderance of new facts, new results, have shown that that hypothesis is correct. We're accepting it. And at that point, where pretty much the entire scientific community recognizes that as the explanation as to where birds are, we start calling it a theory. So the theory of evolution by means of natural selection, that's a theory. The cell theory, the idea that all living things are made of cells, all cells come from pre-existing cells, and the foundation of life processes can be reduced to a cell. That's called the cell theory. You can still question it. It's okay to question it. I started off questioning aspects of evolutionary theory when I was in graduate school. It's good to question. You should question it, because remember we said we're skeptical scientists. You don't take anything at face value. How do you know that? I don't believe that. I think you're, show me the numbers. Where did you get that piece of information? But eventually, these sorts of explanations form the foundation of our general understanding of the way the world works. I'll leave you with a metaphor. Here's the opening to a cave, okay, in a wall, and here you are standing at the opening to that cave, and the sun is shining behind you and casting light into you, and you're looking at your shadow on the back of the cave. This is called Plato came up with this. It's more elaborate than I'm going to describe it, but the basic idea is, and you're interested in what is the physical truth of your body. What is your body? What is it really like? The best you can see, the best you can know about your physical body is the shadow of your body on the back of the cave wall. You can see, yeah, there's a head. Seems like I've got 4 limbs when I do this, but you're never going to know reality the way it really is. Okay, so that's kind of deep, but the best that science can do is give you a general idea of what that physical truth is, but we'll never actually be able to look at it directly.
That wouldn't be the same as your reflection.
Huh?
That wouldn't be the same as your reflection.
Yeah, you can think of it as your reflection. This is a little bit more, because you know the back of the cave wall, it's kind of rocky. Your shadow is distorted a little bit, not quite exactly. There's things going on. I can't see the color of my shirt, you know. So I think shadow is kind of better.
Thank you. I think I'll see it.
You get a general idea, Any questions? I'm sorry, I didn't leave enough time for that. Questions? Quiz Tuesday, 10 minutes. Did you read the chapter? Did you look at your study, your notes? Just kind of,
Chapter 1.
yeah, chapter 1. Bye.
And are you going to put your copy in the library?
I'm gonna do it right now.